Welcome back to True North Mechatronics. We've engineered the sidewalls and the top of our battery box. In this episode, we're designing the tray that our battery sits on. This tray is secured in its tray by a compliant clip. By carefully controlling our wall thickness, we're taking advantage of PLA's limited material flexibility to create a monolithic retention clip built right into the tray. No extra hardware required. This tray will include the 10mm side tab so it snaps perfectly into the bottom sockets of our side panels. Design, engineer, deploy. Let's get into the CAD. Begin by creating a new body and a new sketch on the XY plane. And we're going to use the polyline tool, and we're going to map out one half of our tray just like we did in the previous episode. Now, this is going to have 4 tabs that we're building into this. The 4th tab is actually the retention ledge that will keep the battery from slipping out of the tray on one side. As before, we're going to need to make sure that if any of our line segments weren't horizontally or vertically constrained, that we select them and we constrain them. There's another one there. Now let's set the height of the vertical edges on our tabs so that they're all the same, equal length. This one also needs to be constrained vertically. Now let's set the width of our tabs so that they're the same. The section between these 2 tabs is also going to be set equal. And now let's set the width of the tabs to 10mm. Let's set the height of the tabs to 3mm. Now this gives us a bit of a sense of scale of what this is going to look like. Let's set the distance here between our tabs to 22mm. I'm going to pull this out to about right here, and I'm going to pull this sidewall in here. And I'm going to set the width of this top tab here. This one is 9.8mm. I'm going to pull it in just a little bit like this. And now I'm going to set this bottom line so it is symmetric around the y-axis. And now I'm going to set the length of that line to 104mm. Going to set the sidewall here to 29mm. And now we need to set the length of this edge right here. We're going to set this one to 10mm. Just make sure that we can see all of these constraints. And with that, we have fully constrained the outer shape here for our tray. So now we're going to close out of the Sketcher workbench, and we're going to pad this shape out. And we're going to pad that to 3mm. And we're going to mirror this. So in the tree view, left click on the body, and we're going to mirror this shape. From the plane, we're going to select our own reference, and that's going to be this edge here. And we'll say OK. And now we're going to add the retention ledge on this side here. So let's create a new sketch on the top of our part here. And we're going to reference this edge and the inside parts of this tab. And we're going to use the polyline tool. We're going to trace the outside. And then we're going to come back around the inside. And we're going to make sure that we've got our horizontal and vertical constraints in place, which we do. We're going to set this sidewall of our retention to 2.5mm. So our sketch is fully constrained. We can close out of this, and we're going to pad this out to 5mm. And now we're going to add a chamfer on the edge here. So let's grab this edge here. I'm going to hold down Control, click the next edge, and grab that chamfer tool. We are going to choose the 2-distance type of chamfer. Our first size is going to be 7.3mm, and our second size is going to be 5mm. And when we do that, we get this nice even chamfer here. Extends from the edge downwards. All right, so now that we've got that, We're going to create the truss pattern here in the center. So let's create a new sketch on the top. Going to create our triangles using the polyline tool. And so just like before, we're creating these 4 triangles. And we're being symmetric in how we do this. We will take and fix any lines that aren't horizontally or vertically constrained here. So that one and that one are missing their constraints. So that solves that problem. Let's make these 2 inner triangles so they're symmetric around the y-axis. Let's take the base of all of our triangles and set them equal to each other. And let's take the diagonal portions of our triangles and we'll set them so they're equal to each other. And now we're going to toggle on the construction geometry and we're going to draw construction lines between each of the triangles on the top. Finally, we're going to make sure that these 2 end construction lines are constrained horizontally. And we're going to click on each one of these construction lines and make them equal in length to each other. So now we can set the length of one of the construction lines to 5 millimeters. We're going to set the height of the sidewall of this triangle here to 44 millimeters. And we're going to make this triangle on the end, we're going to make its vertical line symmetric around the x-axis. And that leaves us with 1 degree of freedom here, and that is going to be the distance away from the edge here. So I'm going to grab my external geometry tool, reference that side edge there, and I'm going to create an offset here of 8 millimeters. So our truss pattern is fully constrained now, so I can close out of that and pocket it. And now we're going to rotate around to the front, and we're going to add a shape on the front here. This is going to be the compliant clip that will flex just using the natural flexibility of PLA plastic. So let's put that in there. We're going to make this rectangle symmetric around the y-axis. And we're going to set its width to 10 millimeters. And we'll set its height. Set its height to 1.5 millimeters. So there we are. So that is going to be our base shape for our clip. So we'll close out of this and we'll pad that out and we'll accept the 10 millimeter default. Let's click on the top of the clip that we've created, and now we need to create the actual clip portion that will restrict the movement of the battery once it's in the tray. So we're going to reference that edge there, grab the rectangle tool, and we're going to grab these 2 vertices here and constrain them coincident. And we're going to set this to a width of 2.8 millimeters. And so we can close out of the Sketcher workbench now, and we're going to pad that out to 5 millimeters. Now our clip is going to be right here. We want to make it so that the battery can push over the clip. So we're going to grab this edge here, and we're going to give it a chamfer. And we're going to set that chamfer to 2.4 millimeters. So when we look at it, we can see that we don't want too sharp of a corner here. It's just going to get broken off anyways by the battery as the battery slides back and forth. So that is a useful profile there. Now that we've got that, we need to increase the strength of the joint here where the clip connects to the edge of our tray. So the easiest way to do that, left click on that line there, and we're going to create a chamfer there, and we're going to set this value to 1.4 millimeters. And you can see that we now have this reinforced area, which will keep the clip from breaking off of the tray that we've created here. That pretty much does it for the tray. We're just going to add a cosmetic fillet at the back of the tray here. So I'm going to grab these 2 edges here, and I'm going to give it a fillet of 3 millimeters. So with that now, I have completed the tray. We have fully completed now then a battery box that will secure the battery on the top of the Sparkbot. In the next video, we're moving back to the front of the Sparkbot to tackle its ability to detect obstacles in front of it. We're going to engineer a mounting bracket for our HCSR04 ultrasonic sensor, and we'll anchor this bracket directly to the mobility base. So you'll also see exactly why we created that specific clearance notch in our accessory deck in part 2. It's all about system level planning. And we're also going to model a small shim that's going to go under the metal bracket that attaches the TT gearboxes to our base. We need to increase the height of our motors off that base by 1 millimeter, and so we're going to put both of those parts into the next video. So chart your course, build your world. I'll see you in the next one.